Let's wait for probably around 40 attendees and then we can get started. I think people should pick it up. Perfect. Okay, let's get started. Thanks, guys, for Thanks, folks, for joining us for this session. Uh, the session is Fast API, and the session will be given by Ruslan. Ruslan is currently a lead software engineer at EPAM Systems, and in this topic, we'll be talking about differences with Flask and where Flask is suited better, etc. And Fast API is a high performance web framework for building APIs with Python 3.6 plus. It's built on top of Starlet and Pydantic. Thank you, Ruslan, for joining us. Please take over the session.
Thank you, Tim. Hello, everyone. I am glad to speak in the PyConf Hyderabad. My name is Ruslan, and I'm working at EPAM, St. Petersburg, Russia. The only thing I want to mention about myself is that I'm Python zealot for many years. I started development using Python version 2, then migrated production to version 3, then migrated to version 3.5. I'm still loving Python even after this. My talk is about Flask and FastAPI. Flask is a very popular and powerful framework for backend development. I meet Flask in every modern Python project last years, in many different areas, like machine learning, microservices, Internet of Things, and others. But as engineers, we should ask ourselves, is this tool suitable for the current task? In this talk, we will compare Flask and FastAPI in different areas of usage. We will make some conclusion at the end. So let's go. Why are developers loving Flask? Let's just remember what, for example, Django provides. Templates, ORM, configuration, managed by, migration, fixtures, a lot of stuff. I met some experienced Django developers who cannot create new application without reading the documentation. By the way, to start developing new Flask application, you should just create a Flask app instance and a function with route handler. No generated code is required. Request and app, these global context variables help us to design low-coupling code. Developers don't need to pass requests from one function to another. Import requests from Flask package and use it in every place of your code. Flask is a good starting point for web application creation, but in some cases it could be more profitable to use other tools for backend development. Meet FastAPI. It is a pretty popular tool with about 20,000 stars on GitHub. If you go to official documentation, or to the GitHub to read about FastAPI, in the main page you will find these key features. FastAPI is fast. Okay, at least the Flask is fast enough in most cases. Other features are more weird. Efficient, faster code, fewer bugs, intuitive. But do not be confused. The FastAPI is a very useful tool. Right now, I will try to convince you in it by comparing FastAPI with Flask in real cases. How we will compare them? This is my plan. We will develop a REST API application. Then we will create the endpoint for machine learning model. Finally, we will try FastAPI for microservices development. During this comparison, I will write out some benefits to developers provided by both frameworks. Let's start with REST API. Flask and FastAPI allow us to write routers in the application code directly, without mapping or additional configuration files. You see, this code is pretty similar. Let's change it and allow both get and post methods. HTTP methods in the FastAPI called operations. Decorators with operations could be used together. Thanks to this feature, we don't need to remember additional arguments like methods in Flask. Let's go forward and implement more complicated case. This Flask handler logs in the user. There is only two arguments, username and password. But what if this form will have more than two arguments? What about 5? Flask doesn't help developers to understand what arguments this post request accepts. Moreover, function body could be complicated with arguments checking. Let's write exact same functionality using FastAPI. I've just added additional class creds with required properties. Now it is much easier to figure out what arguments post method accepts. Just see in the creds class and login function signature. FastAPI uses type hints for code readability improvements. If any of you is not familiar with type hinting, here's a quick example. Look into this code. Calling this outputs John Doe with capitalized first character. But what if we change call get full name? For example, we'll replace string Doe with integer 1. For sure, this program will fail in the runtime with an exception, right in the production. Of course, when I use this function by myself, I will note this mistake for 99%. But other developers in my team could not be aware of how this function works. They are not expecting any exceptions here. Moreover, arguments to this function could be passed from HTTP request directly or from other library. We need a tool to explicitly declare types of arguments. That's why you need type hints. These type hints are special syntax that allow declaring the type of variable. Look into this code. Anyone now can understand that first name and last name should be a string. Moreover, modern IDE can even highlight type errors. Python community has a good tools for static type checking, MyPy and PyType. They both are very good. Usually, type checking is a part of continuous integration pipeline, so it guarantees that the function getFullName will not fail in the production because of invalid type. Let's go back and check what benefits we will get from it using FastAPI. Developers who know type hint can easily determine what is expected in the login function. Moreover, IDE suggests fields during development. Using just type hint, FastAPI can generate Swagger documentation. Just run the app and go to docs URL. If something is changed in your code, documentation will be regenerated automatically. Very useful feature. What if I told you that you can create automatic Swagger documentation using Flask tool? Let's install connection dependency for it. Connection is a framework on top of Flask that automatically handles HTTP requests defined using OpenAPI syntax. Operation ID maps the login resource with the login function in app module. Flask should be initialized using connection wrapper. Then you can remove module decorator because map already exists in OpenAPI specification. But the login function still has no any additional information about request body. Check OpenAPI specification to know what fields fields request has. Now we can run app server and voila, Swagger documentation is automatically generated. Pretty similar to Fastapi functionality. The connection requires to write specification using OpenAPI syntax. It could be very complicated because there is no proper and production-ready tooling for it. You will encounter many different error messages if you are not familiar with OpenAPI. Connection not the only one library for REST API building using Flask. You can use Flask REST Plus and Flask REST-X for it. Both libraries creates Swagger documentation from code, but it is required to add special decorators for your roles and create resource classes with method get, put, post, and so on. Let's make a conclusion. Fastapi is a good choice for REST API development because of specification generation using type hint. Flask plus connection, also a good choice, but you should be familiar with OpenAPI syntax. Let's go to the next chapter, machine learning endpoints. Here is a common scheme of HTTP endpoint in front of machine learning model. Python is a very good choice for such endpoints because ML library which is used by data scientists in your company also has a Python interface, no matter what kind of library it is. Let's implement this scheme using Flask. Firstly, we are loading a model. Model has to be loaded before any request because usually it is resource-intensive operation. Then we start in the production 10 instances of our application. You will see how GUnicorns gobble up memory trying to run your code. Hopefully, the OM killer will shut down GUnicorn before we lose control of our server. What is the problem? The main problem is that this configuration will run a load model 10 times in parallel. The preload flag will tell GUnicorn to fork process only after loading our model. So our model will be loaded only once, then model will be copied to another process. It is good to use this flag always in any case. What about Fastapi? Well, let's see. Fastapi used with ASGI server Uvicorn. Uvicorn has no preload flag and has no similar functionality, but you still can use GUnicorn with ASGI worker Unicorn to run your Fastapi application. Here are command line options to use it like with Flask. What's the difference between Uvicorn and GUnicorn? Why the Fastapi requires a different application server? Because Fastapi allows you to write asynchronous code using async syntax. Let me show you its features. Look into this code. It fetches data from URLs and appends result to ACC list. I emulate request using type sleep function. This code will execute slower than 6 seconds because there are 3 items in the URL list, each of it takes at least 2 seconds. Python interpreter do nothing while waiting a result from network request because network request it is an IO-bound operation. This code will run all day long if you have, for example, 20,000 of URLs. Let's rewrite this code using async IO. As you can see here, I added 3 improvements: async await, async IO gather, and async IO run. As a result, this code will be 3 times faster. Let's take a closer look. Fetch from URL is not a regular function. It is a coroutine function. So running this function without await syntax just returns a coroutine object. We are collecting all coroutine objects to the coroutines list. To execute coroutine function, we should call it with await keyword. We are using gather function. It will execute all of the coroutines concurrently using event loop. To start event loop, we are using another function, async IO run. ASGI server UVcorn will start event loop for you, and you can just focus on writing asynchronous code. Let's switch back to Fastapi. Async await keywords could be added to your code if your model supports async IO. We will meet this approach later, but now let's summarize. Use GUnicorn instead UVcorn for preloading models into your application. Fastapi is a good choice to use with asynchronous backend, for example, Elasticsearch. Let's go to the next chapter and compare Fastapi with Flask in microservices. Thanks to the microservices, we can create a complex architecture using small independent pieces of application of software. It's called services. One of the main part of this architecture is that how our microservices communicate to each other. There is 2 ways of communication: synchronous using HTTP, gRPC, TCP protocols, and so on, and asynchronous using different message queues. Here is an example of synchronous communication. Endpoint creates 3 requests on 3 different microservices, one by one. When all results are ready, endpoint forms a result. Remember that we saw how async IO can speed up this code using gather function. The response time of this request will be 3 times faster just using Fastapi with async IO gather. But be careful, the requests library do not support async IO. So you should use something like AOHTTP, for example. Let's see another example. When the endpoint should create 3 sequential requests using the result of previous one to create another one. In this case, you cannot use just gather function to run all requests together. So for one exact request, async IO will not add any gain. But for the whole system, requests per second will increase because the process is not blocked by IO operation and is ready to process other requests concurrently. Therefore, Fastapi can be very productive even on the small computing power instances. So Fastapi could be a good choice if you have many IO operations. Let's see asynchronous communication. Asynchronous communication is asynchronous by design. So You will not get any benefits from Fast API. Moreover, Celery still doesn't support async IO, so Flask is a good enough for this kind of microservices. Let's wrap up microservices. Fast API is a good choice for services with many I/O operations or in microservices with synchronous communication. In other cases, Flask and Fast API are equally good enough. Let's gather all pieces together. Fast API is a very good choice for the REST API development, but if you still need to use Flask, try Connection for Swagger documentation generation. Try to avoid using UVcorn working with machine learning models. Choose Fast API if your machine learning model supports async IO. Microservices development. Fast API is a good choice for services with many I/O operations or in microservices with synchronous communication. For asynchronous communication, Flask and Fast API are equally good. And last but not least, Fast API supports type hinting by design, but do not provide request and add global objects like Flask does. And be careful. I think I/O may be very complicated for beginners. Concurrency requires some experience. These tools are good for particular cases, and I hope material I've just presented will help you to make a right decision. Thank you, and special thanks to my teammates Dmitry Tati and Konstantin Perikov for helping during preparation and translation of this talk. I will be glad to answer your questions right now. Thank you.
So you can ask questions either by raising your hand or typing in the chat.
Yeah. Q&A. Q&A or feed? Just feed.
Yeah, it's can be answered on both Q&A and raised hands, I guess.
I don't see any questions in Q&A.
Yeah. Can we? I think Priya Brata was asking, where do you get the slides? I think in the feed, there's one more person who is asking, do you have recommendations for job queue with Fast API?
Unicorn. What is a coroutine? Coroutine is there is there is two coroutines: coroutines function and coroutines object. It is the first question. What is a coroutine? And coroutine function is any function after Python 3.5 that starts with async keyword. Async def it is a coroutine function, but the coroutine object is a result of this of executing this function of coroutine function without a wait keyword. If you just call coroutine function without await, you will get coroutine object.
There are some questions in the Q&A section.
Cool. How is Fast API different from Sonic? I never use Sonic. Sorry, I cannot. I cannot answer it. Can we say Fast API has a mature environment? It is environment is enough to create production-ready code, and it's yeah. I can say that. How do you feel Fast API as a template platform? Not sure I understand this question. What do you mean template platform?
So
Is
does it have
yeah.
good, does it support Jinja 2 or other templating libraries?
It's yeah. In my opinion, yeah. Of course, it supports. What's the problems? Jinja 2 is a separate library. Uh, in my opinion, Flask it's if you need to create a web site, for example, and you don't want to use Django, you need to use Flask. Better to use Flask, not FastAPI. FastAPI is a different. It is a different framework. It's for REST API creation and for microservices and for front end for before machine learning models. Um, it, you even still use FastAPI for template creation, but it's not the main purpose for this tool.
Another question is, how do you and like how do you achieve background processing, or do you have any recommendations for job queue with fast API?
Um, no, I it's you can use any job you with FastAPI. It's no any recommendation.
Okay.
I have no any recommendation for it.
Okay, so how do you? So this is a question for me as well. So how do you um, work with background job processing? For example, in Fast API, can I send an email after I hit an API endpoint and in the background? Can I do that with Fast API? Probably that's the question.
Yes, of course you can do it, but it is not a main purpose because FastAPI is for asynchronous. Yeah, I understand it. Better use for this. Better use Celery. It's my recommendation. Um, you are processing request, and this request will should be create some result. Yeah, and if you want to create some coroutines from it, it will be it will be complex task for that. It's better and easier to just create the task you using Celery and forget about it. And it's similar to how to use with Flask.
Okay.
As I answered your question.
Yeah. I think Sanchit is asking, what are the best use cases where we shall prefer Fast API over Flask or Django?
Um, as I where you can is it in Q&A? How do I feel FastAPI
Yeah,
is
it's
better?
in Q&A. Yeah.
Uh, use FastAPI when you need to create HTTP REST API HTTP endpoints. It is a very powerful tool for this. Use FastAPI if you have asynchronous backend instead Flask. For example, if you need to create multiply requests to other HTTP services, and use Flask when you create websites with templates, with complex business logic, and with render to front end, and use Django when when you want.
Right. I think there's another question. Is there any alternative to UVCon?
Yes. Yes, it is, but Uvicorn is more mature right now, and Uvicorn is just ASGI server, and you can use Uvicorn with different event loop backends. For example, Uvicorn right now supports, as I remember, UV loop.
Yeah,
It's UV Loop. It's software. It's a library for Node. It was created for Node.js. It's a faster UV Loop. It's a faster event loop, and but you can choose any other to this. You can UV is and Junicorn are brothers, and you can use Unicorn from GUnicorn. I showed in slides how to do it.
got it. Another question would be, I think, what are the best use? No, I think that's been answered. So, is there any? Sorry, that's been answered. So, I think Sandeep is asking, where can we get the slides of this presentation? Can you
Is
share
it
the
like?
slides?
Yeah, of course, no problem. I can share the slides. I send it to this PyConf.
It's Zulip chat,
I
right?
Yeah, I can share it. I can
Perfect.
put in my
Yeah. Yeah,
in
I
my
think I think Russ will share the slides on Zulip after the session. I'll coordinate with him to get that done.
okay.
And I think another question would be: does Fast API for deployment require any type of special servers? Do all servers support ASJA? And probably I have a follow up to this question. So does it work well with a reverse proxy like Nginx or a normal web server like Apache? I mean, how do you do usually deployment, and does it sit well with Docker, Kubernetes? Like, is there anything special that we need to take
No,
care of?
it's not anything special. As you deploy Flask application, you can deploy Fast API application. No difference. And usually I use with Nginx. Yes, Nginx. It's like front end, and then I use ASGI and many ASGI servers and Nginx balance between ASGI servers. It's pretty similar configuration. I haven't used with Apache. I haven't used Apache about 10 years.
Okay. The next question would be, which is better, Starlet or Fast API?
So, I didn't use Starlet. No,
Right.
don't know. But this approach I just showed you, you can do it yourself. Try Fast API in different cases, try Starlet in different cases, and compare what is easier. It will take you, for example, one weekend, and you will know and will prepare another talk what is better, Starlet or Fast API.
I have a question with respect to deployment, right? So most of the C-based ASDI servers, C-based ASDI servers like Unicon and Junicon, usually work on Linux machines or
Yes.
Unix-based machines. I've seen that these libraries are not really supported on Windows. So yes, Python has Windows-based, web server gateway interface servers like Waitress, but I don't think it has any other ASGI, or I'm not aware of any ASGI servers on Windows. So does FastAPI work well on Windows environment?
Didn't try it. I tried on my Mac. I tried on Linux, and it works great. I didn't try it Windows, and in my opinion, using Windows Server for this kind of jobs is not a proper decision. But you always can install Docker with on Windows and from virtual machine and use it like in Windows.
Got it. Okay, so I think we are running out of time here. I think we have 2 minutes more than what we have. So if you have any other questions, I think Ruslan can actually answer in one of the lounges.
Yes.
So thanks a lot, Russ, for joining us and giving us your insights on Fast API. I'm pretty sure people have really benefited from this insight. Thanks a lot, and let's move on to the next session. Thank you.
Thank you, Tim.